Hi folks, we're going to take a look at the solution to page 415, number 9. So they give us this parallelogram OBCA with these vectors going from O to A and O to B that define the parallelogram, and the fourth vertex is called C. So this is what they're asking. So first of all, they're telling us that a line is drawn from B perpendicular to the side AC. Okay, so we're starting at B and we're drawing a line to AC in such a way that it's perpendicular. So this line here is going to look something like this. So right angle, perpendicular. Okay, and it tells us that it intersects AC at the point N. Okay, and what they want is they want to determine the length of this line BN. Okay, so what we're looking for is this length here. Okay, which I guess, we can call the magnitude of the vector Bn. This is what we're looking for. Okay, so there's several ways you can solve this. I'd say a more complicated way to solve it, in case you don't think of the trick I'm going to use here, is, you could say, well, this vector here, this length here, is the same as the magnitude of A. So that's the hypotenuse of this right angle triangle. And this angle in the right angle triangle is the same as the angle on this side that connects vectors A and B. So you can use the dot product to find this angle, use the magnitude to find this length, and use trigonometry. And that would be a perfectly good way to solve this problem, but there's something even easier. Okay, if you look at what this line represents, okay, it's going from one of the vertices perpendicular to the opposite side. So what Bn really represents is it just represents the height of this parallelogram. Okay, and then of course AC, which has the same length as OB, just represents the base of this parallelogram. And of course, the area is just given by the cross product. Okay, so we can solve this problem even though it does involve the angle. By using the cross product, we can avoid using the angle altogether, because we know that the area of the parallelogram is given by the magnitude of the cross product, A cross B. Okay, we know that the base of the parallelogram, if this is the height that I'm using, is just going to be the magnitude of AC, okay, which is the same as the magnitude of OB. Okay, and then the height is just that length that we're looking for, the magnitude of Bn. Okay, so, and of course the relationship is area is equal to base times height. You can solve for Bn. Okay, so area is equal to base times height. So the area is given by the absolute value, the magnitude of the vector A cross B. So 4, 2, 4 cross 3, 1, 4. Okay, which I'll calculate on the side. Okay, the base is just given by the magnitude of OB. So the magnitude of 3, 1, 4. Okay, and then the height is just what we're looking for, which is just that magnitude of Bn. Okay, so on the side I'll calculate this cross product. Okay, so 4, 2, 4. Okay, add the extra 4 on the end because that's the x value, and then here we have 3, 1, 4, and add the 3. Okay, so here the x value of the cross product is going to be 8 minus 4, which is 4. Here we're going to have 12 minus 16, negative 4, and then here we're going to have 4 minus 6, which is negative 2. Okay, so there's my cross product. Here this is just going to be the magnitude, so square root of 3 squared plus 1 squared plus 4 squared. This is just my variable that I'm looking for. So here what do we have? We have the square root of 4 squared plus negative 4 squared plus negative 2 squared. Okay, here we have 16 plus 9 is 25, 26, so root 26 times magnitude of Bn. Okay, and here what do we have? We have 16 plus 16 is 32, plus 4 is 36, so that's just equal to 6. Okay, the area of the parallelogram. And so the length that we're looking for, which is the magnitude of that vector Bn, is just equal to 6 over 26. Okay? So just to recap, what did we do? We first of all drew ourselves a good diagram. In drawing this line that they told us to draw from B to AC in a perpendicular fashion, helped us realize that what we found was just the height of this parallelogram, okay? And the base just given by AC is the same as the magnitude of the vector OB. And so from there, we could use our area formula for a parallelogram to solve for the side that we were looking for. Okay, that's it for this one.